In this video, we learn about the macroprocessors. So, a macro instruction will be used as a notational convenience for the programmer. So, macro instruction usually it will be abbreviated as a macro, and the macroprocessor it replaces each macro invocation with some sequence of statements, and this process will be called as the expanding of macros. So, some group of statements will be there, and these group of statements will be replacing the macro instruction or the macro. So hence it allows the programmer to write in a shorthand version of some program, and this process will be called as the module programming. So main function of the macro is like substituting some group of characters or lines in place of a macro statement. Then for this process, it recognizes the macro definitions, saves the macro definition, recognize the macro calls, expand macro calls. These are some of the steps that is done. Then source code with the macro will be given to the macroprocessor. It expands the code, and compiler or assembler will be generating the object code. So macroprocessor, it will be recognizing the macro definitions, and when it identifies the macro calls, it replaces the statements for that macro invocation statement or that macro call. Hence you will be getting the expanded code, and from this expanded code will be given as input to the assembler to generate the object code. So the main first we will be dealing with the main functions of the macroprocessor, which involves the macro definition and expansion. So starting with macro definition, it includes the copy code and parameter substitution. So copy code is like we can see with an example. So you will be having a source code like strg macro. So as you all know, it will be having a label field, then the opcode field, and then operand field for any program. So if a macro is found in the opcode field, then it means that the following statements, till it reaches to the meant directive, they are considered to be the macro definition for the name strg. Okay, the label is given in the macro name will be given in the label field. And if this label is found in the opcode field, it means that it is a macro invocation statement. So these strg2 statements, it will be found in the opcode field, and then it will be called as the macro call or macro invocation statement. So as we have said, macroprocessor, it will be replacing this macro invocation or macro statement using the set of statements given in the macro definition. So the expanded source code will be like, when the first strg statement is invoked, it will be replaced with the statements sta, data 1, stb, data 2, stx, data 3. And second strg, when it is being used, again that strg will be replaced with these three set of statements that is given in the macro definition. So, macro, the statement of expansion are generated each time the macro are invoked, and in case of subroutine, the statement in a subroutine, it appears only once. So that is the difference, main difference between the macro and subroutine. Another function that is being done in macro definition apart from this copy code is parameter substitution. So copy code is like some set of statements will be copied in the place of macro invocation statement or macro call. So parameter substitution is like, if the macro is having some set of parameters in the form of arguments, like here it is given strg macro ampersand A1, ampersand A2, ampersand A3. So the parameters will be given in the form of ampersand. And the statements STA, STB, STX having the parameters ampersand A1, ampersand A2, ampersand A3. It means that when a macro invocation is being done, it will be given 3 parameters as the actual arguments, and these arguments will be placed. For example, if strg data 1, data 2, data 3 means data 1 will be given in ampersand A1, data 2 ampersand A2, data 3 ampersand A3. So in place of these parameters, the actual parameters will be placed, resulting in these expanded code like this: data 1, data 2, data 3. And when the second strg is called, the arguments will be replaced with the given arguments data 4, data 5 and data 6. That is parameter substitution. So it consists of some arguments. These arguments can be a positional argument or the keyword argument. And positional argument will be like it follows the position of each argument. strg data 1, data 2, data 3, which means first position data will be placed. Data 1 will be in the first position, data 2. So here position is being considered. And if there is null arguments, if we are giving, means in second example, gener, that is some macro giving some arguments, this much arguments, where direct will be the third argument and 3 will be the last argument. In between no arguments are given, so separated with commas. Similarly, in case of keyword argument, you can give the there is no specific order is there. In case of position argument, an order is mandatory. We need to specify the order in which it will be given. Parameter will be substituted in the same order in which the actual arguments are given. In case of keyword argument, no such ordering of the parameters are required. Just we need to specify the keywords of, that is, if inside the formal arguments, if we have used ampersand A1, A2, A3, etc. like that, if we have used, means we need to mention those keywords. So you can pass the arguments like this: strg ampersand A3 is equal to data 1, ampersand A2 is equal to data 2, ampersand A1 is equal to data 3. So this is allowed in case of keyword argument. And for second case, gener, instead of separating with null parameters, that is instead of giving commas and separating the positions, you can just specify that keyword type is equal to direct and channel is equal to 3, where type and direct will be the third and last arguments given in the macro definition. Then we have given some example in the textbook also. We can deal with that example also. So in this case, here also we will be making use of 2 records, rdbuff and wrbuff. So here, as we have said, in the opcode field, if macro is found, means readbuff will be the macro name, and following the macro statement till it reaches the mend directive will be considered to be as the macro definition. That is the statements which need to be used when rdbuff is encountered in the opcode field. Similar is the case with wrbuff also. So in this case, we have used rdbuff fields having ampersand in device, ampersand buff address, ampersand record length, REC LTH. So as you have seen, in these parameters will be used here also inside the body of the macro definition. So when a macro invocation is being done, that is here macro rdbuff is found in the opcode field, which means that this statement is the macro invocation statement. It is having a label and followed with some list of arguments. So what happens? This statement will be replaced with the set of statements that is given in the macro definition, and F1 buffer length will be placed on the parameters ampersand buff address and ampersand record length. Okay, so these variables will be substituted in these places. And so this program will be given as input to the macroprocessor, and the result will be like this. That is, the output of macroprocessor will be like this. That is, you will be having in place of this RDBuff, that is the invocation statement, C loop, the statements that is given in the RDBuff will be placed. Okay. So RDBuff STX record length. So till here, STX length. Then it continues with the main program. That is main program C loop. So this is the invocation statement. RDBuff was the invocation statement. It was replaced with the invocations definition statement that is given in the RDF. And LDA, after replacing this single statement with the definition of RDBuff, it will be continuing with LDA length is comp till it reaches J's C loop. Similar is the case here. LDA comp till it reaches to the C loop. Okay, so this till here the main program will be there, and in between you can see that while doing the expansion, it makes use of the statement, that is jump if equals star plus 11, which means that jump if equals from the main program, it made use of a notation like star plus 11, which means it need to jump to some loop, some label. So here 11 bytes it need to jump. So as you all know, each instruction will be taking 3 bytes. So STH3, then 6, 9, then comes STX will be in the 10th position and length will be in the 11th position. Okay, so save the record length. So instead of using any other labels, it makes use of this instruction in the macro for jumping to some specific statement. Similar, check this also. It checks for the maximum length, that is, and if it is less than, if it doesn't reach to the maximum length, means we need to move to the we need to move to get the character, next character. So in this case, in order to get the next character, what it does, jump less than star minus 19. So in this case also you need to you need to decrement the address. So for that, what we need to do, star minus 19. So this becomes 3, 6, 9, 12, 15, 18. Then here, here it is 21. Listen, in order to fetch the instruction, you need to take the address as 21. But in order to get the input from the we need to fetch it from the input device. So 3, 6, 9, 12, 15, 16, 19. Okay, from this, so here we can see one more example, that is in this case jump equals star minus 3. So what is the function of these two statements? We have seen in the previous case also, that is TD is testing the device F1. F1 will be some input device. Okay, so for this it will be testing the input device. Jump if equals star minus 3. So for what purpose it is testing? In order to read the character from this input device and load it to the register. So it checks whether the input device is ready. So it loops until the input device is ready. So star minus 3 means to go to this instruction TD. That is current PC value will be deducted by the current that is minus 3. It will be deducted by minus 3 in order to test for the input device. Okay, similar is the case here. Once the input device is ready to give the data, then it will be reading the character RD from the input device. So similar is the case that we have said earlier, that is star minus 19. So which means that it jumps to this, it jumps in order to fetch the character from the input device. Okay, so it checks for the input whether it is ready. That's why it is jumping to this statement. Star minus 19, 3, 6, 9, 12, 15, 18. So here TD will be like 21, but we need to move to the input device F1. So 19 will, F1 will be occupying 1 byte. So it will be moving to the 19th instruction, that is deducting to 19th byte. You will be getting the device in which it checks whether the device is ready to get the read the input. That is here. Similar is the case done here also. Minus 14, jump less than minus 14. So here also it need to move to the 14th byte. So 3, 6, 9, 12. Here it becomes a 15. 15 means the entire instruction including this LDCH. So LDCH will be taking 1 byte, and 15 will be like you can get character from the buffer. Okay, so the process will process to get the character until it reaches the maximum length will be done here. Okay, so this is the purpose of usage of this instruction. So this main program, if it finds the macro name or the RDBF in the opcode field, then that RDBF statement will be replaced with the macro definition. So the output will be like this. So in this case, one more thing that we need to know is labels will be retained. Okay, labels will be retained so that it will be acting as an assembler mnemonic. So it will be retained in the output of the macroprocessor. Later you will be learning how this labels will be maintained. Unique labels also will be generated if the macros are repeatedly called inside a program. So macro definition within macros, process macro definition during expansion time. So if there is any nested macro, it will be like this. Macros, the RDBF will be another macro, WRF another macro that is defined in this macros. Macros is a macro which is having two macros, RDBF and WRBuf. That is, they are defined inside one macro. So how many macros are there? Corresponding main directives also need to be included. So how it is being implemented? We make use of some algorithms or data structures similar to the case of assemblers and loaders. Macroprocessor will be also following some algorithm. So it makes use of three data structures like def tab, name tab and arc tab. Name tab will be having the name of the macro followed with this some starting and ending linked to the def tab. Def tab will be having the definition of the macro. Okay, the definition statements will be included in the def tab, and its start and end pointers will be stored in the name tab together with its name of the macro. Then arc tab will be having the arguments, like here we are having ampersand in the ampersand buff address, then ampersand record length. So these things will be stored in the arc tab. So their position also will be managed here, like here during the expanding process. Here question mark 1, it indicates that it uses the first one, that is and in div, and question mark 2 indicates it will be using the second one, ampersand buff address, and question mark 3 that indicates the record length. So with the help of arc tab you will be able to identify the positions of each arguments. So starting with the algorithm, one pass macroprocessor. In case of one pass macroprocessor, main requirement is every macro must be defined before it is being called. So it makes use of two definitions, define and expand. As we have said, we are having the data structures that is used, name tab, def tab and arc tab. It will be used inside two procedures, define and expand. So process line will be the main how the macroprocessor is being processing each and every lines. It can be a simple instruction or a macro instruction or a macro call it can be. So process line, if it is a macro definition, means it will be invoking the define procedure, and if it is a macro call statement, means it will be invoking an expand procedure. So if so this is the main program to process the macro operations. So begin macroprocessor, expanding will be equal to false, that is it is not expanding any macro. While code not equal to went, do getLine. GetLine means from the source input program it will be reading each line, or it will be processing each line, reading each line. Then process line is it checks whether it is a macro call or macro definition statement, it will check, that is process line. So getLine procedure can be defined like this, procedure getLine. If expanding, that is expanding will be equal to true if it is a macro statement, and if it is a macro statement means that is macro call statement. If it is a macro call statement means some set of statements will be stored in the def tab, which will be taken in the place of the macro invocation statement, that is replacing the statements given in the def tab, replacing the statements macro invocation statement with the statements given in the def tab. Okay, so if so that process, that is if it is a macro call, means expanding will be set as true. So if expanding, what it does, it gets the next line of macro definition from the def tab, substitutes the arguments from the arc tab for positional notation. That is, while expanding it substitutes the arguments from the arc tab, like representing the positional notation. Then read next line from the input file. If that is, once the expanding is false, which means once it reaches to the end of the def tab, then it expanding will be set as false, and you need to take the next input line from the input file. So this is the task of get line. Then related to process line, what it does, searches the name tab for the opcode. So that there will be some name given in the opcode field. If it searches the name, if it is a macro call, means that name will be found in the name tab. So if found, expand procedure will be invoked. And instead of the name, if it is not found, it will check whether the opcode is equal to macro. Then if it is a macro, means define procedure will be invoked. And if both these conditions not satisfied, means write the source line to the expanded file. Directly, what is the source that is given, it will be returned to the expanded file. So the process line is like, it checks whether it is an expansion call or a definition, it checks. If it is a call, means opcode value will be found in the name tab. Then it calls the expand procedure. If it is a defined statement, means opcode, in place of opcode, you will be getting the directive macro, and then it calls the define procedure. Now you need to know about the define and expand procedure. So define is like, enter the macro name to the name tab. So you will be having a macro definition. So name will be there in the label field. So that name will be loaded into the name tab. And then enter the macro prototype into the def tab. Macro prototype means that first statement of the macro definition, which includes the formal parameters. It will be loaded into the def tab. Level is equal to 1, which means in order to monitor the nested macro statements. Okay, if there is any nested macro definition, means we need to monitor that. If it encounters with nested macro statements, macro definitions, then the level will be incremented by 1. So first macro, when it encounters, level will be equal to 1. While level greater than 0, do get line. So it gets line from the input file, checks for whether it is a command line. If it is not a command line, then substitute positional notation for the parameters. First is, you need to substitute the positional notation for the parameters taken from the arc tab. Then enter that particular line into the def tab. After substituting the positional notation, place it on the def tab. If opcode is equal to macro, while reading the line from reading the line and placing on to the def tab, if it encounters with the macro in the opcode field, then it need to increment the level by 1, which means a nested macro definition is being encountered. Else opcode, it checks whether the opcode is meant. Okay, if more than one macro definitions is there, means more than one meant also will be there. So equivalent meant opcode, if it is found, means level will be equal to level minus 1. So these two things also it will check. Okay, so in define procedure, it enters the name of the macro into the name tab, and then the prototype will be entered into the def tab. Level will be monitored, and it substitutes it takes each line by line it takes, and if there is any parameters in place of that parameters, it will be substituting the positional notation for the parameters, and then enters the line into the def tab. While entering, it also checks whether it encounters with the macro in the opcode field. If macro is found in the opcode field, then level will be incremented by 1. Else opcode, if it is meant is found, then the level will be decremented by 1. store in name tab pointers to the beginning and end of the definition in order to track the beginning. So moving on to the expand procedure. In this expand procedure means in the opcode field it might have encountered with the macro name. So in that expanding will be set as true. Get the first line of macro definition from the def tab. So the first line of macro definition will be the prototype, that is the declaration part. The first line will be taken from the def tab. Set up arguments from macro invocation in arc tab, which means in the macro invocation you will be having the actual arguments which will be loaded into the arc tab. So arc tab will be having some parameters, that is the actual parameters given in the macro invocation statement. Write macro invocation to the expanded file as a command, which means in the example we have seen a dot followed with some statements. So as a command you will be writing the macro invocation in the expanded file. And then write not while not end of macro definition, do get line. So get line will be done. So what is the get line procedure? It does two things. It checks whether the expanding is equal to true. If expanding is equal to true means it gets the line from the def tab. Substitute the arguments from arc tab for the positional notation. So arc tab will be having the actual arguments, and in place of the positional notation, that is you will be having some question mark 1, question mark 2, like that it will be having, and in place of those positional notation the actual values will be substituted. This is the one thing that is done by the get line procedure. And the second one is like, if the expanding is not true, what it does, it reads the next line from the input file. So that is the actual file that is given as an input to the macroprocessor. It takes the next line from the input file. Then process the line. So process line is like, it checks for whether it is an expand procedure or that is whether it is a macro call or a macro definition, that is process line. Then once it reaches to the end of the def tab, that is the last one, the mend directive, when it reaches, what it does, it sets the expanding equal to false. So expand, it does mainly two things, that is it takes the arguments to the arc tab and then processes the line, gets line from the def tab till it reaches to the end of the, that is till it encounters with the mend directive. It processes each and every line, whether it is a macro call or macro definition. Once it reaches to the mend directive, expanding will be set to false. That mend directive means it will be reaching to the end of the def tab, for that is expanding that macro name. So this is the algorithm for macroprocessor, one pass macroprocessor. So everything will be defined before it is being called. We make use of these procedures defined at expander.